So hello everyone again and welcome to my channel. So in here we're going to look at something quite interesting, which is formal charge. Now in this particular concept here, you have to note that this is quite different from partial charge overall. So one of the differences between partial charge and formal charge is that partial charge tends to require the calculations from electronegativity series, and being able to recognize that enables we to be able to know which particular element is going to be involved in the generation of either the partial positive charge or the partial negative charge overall. On the other hand, if you're looking at formal charge necessarily doesn't require that particular concept of electronegativity. Sometimes it does, sometimes it doesn't. So that's one of the key differences between that. And on the other side, partial charge tends to be more realistic in a way compared to formal charge, which is less realistic. However, formal charge can be quite important when you're looking at a specific species that is involved in the charge distribution compared to looking at the whole molecule overall. But anyways, before talking too much, let's just talk about formal charge truly looks at. So formal charge tends to keep track of electrons overall, and keeping track of electrons is really important in organic chemistry, involved in organic compounds that are involved, in reactions, and from there you can know where this charge is going to push electrons to or which charge is going to receive electrons from. Overall, this may sometimes or may not be responsible for the real charge overall, so you need to note that difference here. And in this case we are going to, this also helps us to show the atoms with the most charge in overall charge molecule, and also sometimes in neutron molecules. Sometimes neutron molecules, we don't know that they have charge in them, but if you look at inside the whole molecule, you might see pretty much positive charge, negative charge, positive charge, negative charge. But if you look at the sum of all the charges over here, we consider it to be zero, which is a neutral molecule overall. But we're going to look at this in details in future videos and various examples of this particular situation happening in here. So the calculation for formal charge is quite not that complicated, to be honest. So FC, which is formal charge, involves the knowing the group number of the particular atom. Group number means that you're looking at pretty much the valence electrons that this particular element possesses, and if you subtract that from the, if you subtract that, or if you like have that total number of the valence number of electrons, then you have to also consider the number of non-bonding electrons that same element possesses, and also you need to take into consideration the bonding pairs that is surrounding the particular element, or I will say have the number of shared electrons. So in this case now, once you're able to know the number of bonding electrons and also you know the number of bonding pairs, if you subtract the total of these two from the group number or the valence electrons, you should be able to determine the formal charge of the particular element in the whole compound. So let's take for an example, you have CH4. CH4 is methane, of course, and if you draw the Lewis structure for this particular compound, what you realize is that you have C attached to 4 hydrogen atoms, and what you realize in here is that even look at the periodic table, what group number carbon is 4, so this is for carbon. the group number is 4, subtract that from the number of non-bonding elements in here, non-bonding electrons in here, we realize that there is no non-bonding electrons around this carbon, so we put 0. And then we look at the number of bonding pairs. In here we have 1, 2, 3, 4, which have 4. Or if you say shared electrons, then in here we have 1, 2, 3, 4, 5, 6, 7, 8. 8 divided by 2 gives you 4. 4 minus 4 equals 0. So in here, the overall molecule has a 0 charge in this particular case, because carbon here has a 0 formal charge. Now, if you look at another example, hydronium ion with a positive charge. Now this is quite interesting. If we draw the Lewis structure for this, what you realize is that oxygen is bounded to 3 hydrogen atoms, and then has also a lone pair. And once this lone pair is being introduced over here, if you add a positive charge, we don't actually know where the positive charge is, but before that, let's just confirm that this positive charge over here is actually on the oxygen. Now let's look at oxygen. Oxygen over here is in group 6, so it has 6 electrons, or 6 valence electrons. So 6 minus non-bonding element electrons, we have 1, 2, 2, and bonding pairs. The bonding pairs it has is 1, 2, 3, 3, or number of shared electrons are 1, 2, 3, 4, 5, 6. 6 divided by 2 gives you 3. 6 minus 2 minus 3 gives me plus 1. So the plus 1 is actually on the oxygen atom, but sometimes we usually write these as the overall charge of hydronium to be plus. But in here, formal charge makes we to know which specific species actually owns that particular charge, or where the charge is mostly positioned in this particular molecule. Overall, thanks for watching, and I'm going to be posting a video on various of problem solving involving other compounds that exhibit this kind of charge distribution in nature overall. Anyways, thanks for watching. Please don't forget to hit the like button, share and subscribe to everyone around there. Have a good day, guys. Peace, love you all, and be smart.